This is lesson 7.3. So today we're going to talk about ways to prove that a quadrilateral is a parallelogram. So in our last lesson we learned all the different things we know are true when we know something's a parallelogram. So now almost all of those that we learned can also be used to apply determining if it's a parallelogram. So we can use the definition of a parallelogram to prove something's a parallelogram by determining if we have two pairs of opposite sides that are parallel. So our first example here, if I knew that angle ABD and angle CDB are congruent, then I can say that AB is parallel to DC by the alternate interior angle converse. The lines are parallel because those alternate interior angles are congruent. And I can also say that because these angles here are congruent, the top and bottom are parallel. So I could say AD is parallel to BC by the alternate interior angle converse. So now I can say that ADCB is a parallelogram by the definition of parallelogram, because we've shown that we had two pairs of parallel sides. We could also have just described it, ADCB as a parallelogram, because both pairs opposite sides are parallel. Both answers perfectly acceptable. Other ways, so here's some properties that we talked about. If both pairs of opposite sides are congruent, if both pairs of opposite angles are congruent, if the diagonals bisect each other, and if all consecutive angles are supplementary. So the difference between these and the properties we learned is now we have to look at both, right? It's not okay just to know that one of the diagonals got cut in half. They have to bisect each other. Not just okay that you know one pair of opposite angles are congruent. It has to be both pairs. It has to be all the consecutive angles are supplementary. So in B, I see I have a side that's 35 and a side that's 35, so those are congruent. I have a side that's 20, a side that's 20, so those are congruent. So this is by both pairs of opposite sides congruent. So we're really just stating what we see happening in the picture. In C, we are told that A is the midpoint of CE, so those are the same, and A is the midpoint of BD, so those are the same. So in this picture, it's because or by the fact that the diagonals bisect each other. The last way we're going to learn about how to prove that a quadrilateral is a parallelogram is if one pair of opposite sides is both parallel and congruent. It has to be the same pair of sides. So if the top and bottom were congruent but these sides were parallel, that wouldn't be enough information. It has to be the top and bottom parallel and the top and bottom congruent, or the sides parallel and the sides congruent. So in our last part of example 1, explain how this quadrilateral is a parallelogram. Well, we do know that FG and JH are congruent, and I also know that FG is parallel to JH, right? These angles here are consecutive, interior, and they're supplementary. So that's the consecutive interior angle converse. So it is the quad is a parallelogram because one pair of opposite sides is parallel and congruent. Right? We saw that they were congruent because they were both 14, and we were able to prove they were parallel by the consecutive interior angle converse. So here are some problems for you to try. Pause. Answers are posted online. So here's some ways to prove that a quadrilateral is a parallelogram in the coordinate plane. We can show that both pairs of opposite sides are parallel. We know that we could show lines are parallel using the slope formula, which is written down here right now. We can use both pairs of opposite sides are congruent. That would be using the distance formula, which is almost written out down here. Uh, we could use the fact that diagonals bisect each other. And the one that's not listed here for some reason is we could do that last one we just learned. One pair of opposite sides is parallel and congruent. That's actually my favorite way because there's going to be a sneaky way for us to take the slope work that we did and apply it to the distance formula. So we see here slope was y2 minus y1 over x2 minus x1. If you recall the distance formula, come on, doesn't want to help me now? Let's try it with this. Nope. There we go. That belongs there, and that belongs there. So if I've already done the work in the slope, I can move the numbers from the slope into the distance formula. And that shortens up my time. And it doesn't matter which way we had it. These can be flopped, and it's not going to make a difference to me. Right? That's still going to be the same thing because addition happens either way. So we are going to make a table when I'm doing this, and I'm going to choose one of those methods. I'm going to either find 4 slopes, I'm going to find 4 distances, I'm going to find 2 slopes and the matching 2 distances, or we could do some midpoint stuff for that diagonal, but I'm not going to worry about that. I find these other ways to be more beneficial because they will apply to other problems later on. So the table I'm going to make for this one is I'm just going to find the slope of these 4 lines. So I'm going to make a little table here, and I'm going to have a spot to do all my slope work, and I'm going to have a spot to put the sides of my figure. If it's KLMN, KL is a side, LM is a side, MN is a side, and then going back N to K is our last side. So if it helps you, use the order that they give you the name of the quadrilateral, and you're just going to take 2 letters at a time, working your way through them, and those are your sides. So now let's do our slope. So for KL, we have 4 minus 3. I'm going to ask that you show your work because this is a coordinate proof. So I do need to see what you were plugging in to do this work. So there's our slope of KL. For ML or LM, we have negative 2 minus 4 over 7 minus 8. For MN, we have negative 3 minus negative 2 and 1 minus 7. And then for NK, we have negative 3 minus 3 and 2 minus 1. Oh, I did that backwards. Negative 3 minus 3, 1 minus 2. I knew something didn't look right there. I have a dog barking in the background, and I'm distracted. Negative 6 for negative 1 is 6. So I can see, and now this is the important part of the proof, doing the work is one step, but now we have to describe what we found. We found KL had a slope of 1,6 and MN had a slope of 1,6, so we have found that KL is parallel to MN. We saw LM and NK both had slopes of 6, so we also showed that LM is parallel to NK. So overall, KLMN is a parallelogram because both pairs of opposite sides are parallel. We also could have said because of the definition of parallelogram, but I tend to write exactly what it is that I found, and I found both pairs of opposite sides are parallel. Let's do another example together. We're going to do this one differently. So I have the coordinates of FGHJ, and I want to prove that this figure is a parallelogram. This one I'm going to do my slope and distance combined. So there's only 2 sides I'm going to do this work for. So FG is a side. GH would be the side next to it. Like if I were to draw this out. FGHJ. So FG is not opposite GH, so I wouldn't go to GH next. I would skip to HJ because that's opposite the FG, and then FJ would have been my side opposite GH. So these are the two I'm going to work with. So let's start with slope. So that's going to be 2 minus 4 over 4 minus negative 2. It's a slope of negative 1/3. And for HJ, we have 0 minus negative 2 and negative 2 minus 4. Slope of negative 1/3. So already I have shown that FG is parallel to HJ. And now let's do our distance. And I'm going to do my sneaky little distance trick. I'm going to take the numbers I got when I did 2 minus 4 and when I did 4 plus 2. Not the reduced numbers, because that's not what I got when I did 2 minus 4 and 4 plus 2. I'm going to use the negative 2 and the 6. So that's going to be negative 2 squared plus 6 squared. So that's 4 plus 36. That is 40. Same thing for HJ. I'm going to take the unsimplified numbers, the 2 and the negative 6. So that's 2 squared and negative 6 squared. That's 4 plus 36. That also equals the square root of 40. So we have also proved that FG is congruent to HJ. So FGHJ is a parallelogram because one pair of opposite sides is parallel and congruent. So here is the last try problem. You can choose whatever method you like to prove that it is a parallelogram. The answers that are posted online are going to have a lot more work on them than what you would have needed to do because I don't know which way you chose to do. So that is the end of section 7.3.